Good afternoon, and thanks also from my side towards the SCT for the opportunity to present here today, and for myself as a market director service provider within Skyline Communications, who's focusing on OSS, NMS, and orchestration. Basically, my role in the company is to make sure that I stay in touch with the challenges for yourself as a service provider and make sure that our proposition can evolve along with your requirements, expectations towards solutions as ours. Now, following the presentation of the first speaker, what I think today, what I'm going to talk about as the evolution in the service delivery infrastructure to our distributed access is, I think, an excellent example why today analytics, so artificial intelligence and machine learning, has become an integral part of the solution. We see forward that it's impossible to proceed without, because there is upfront investments required also from our side. I think since 5 years, we now have a team of PhDs in maths that are dedicated. They are basically growing in importance, also in numbers within the company, and that's the only thing they do. And they make sure that basically we can have that capability built in, and so we can have this support all along the process, because it's important that to realize, and I'm going to get started in my presentation right away, that there is obviously benefits in testing, and there's also benefits when it comes to incident prediction, and so reducing the root cause analysis and so on. But also for us, there's also a lot of gain when it comes to relieving our customers from the necessity to set thresholds, for example. In the past, people said, what are we going to use as an alarm threshold? Today, there's lots of parameters, KPIs, where you cannot set the threshold. It's just senseless to do a setting. You need to rely on basically the machine to learn what is normal, to see the trends as they go along, and then flag to you when they've spotted something that isn't normal, that hasn't been there before. So, first of all, distributed access. Why is this getting so much traction in industry? Why is everybody going there? I think the sense is that cable operators, they don't exist anymore. I think we've all become a service provider with a hybrid access infrastructure. And so we're seeking ways to return maximum investment on our fiber infrastructure in place. Means that we try to put convergence as deep as possible into the access space to generate a maximum return on investment, evolving to a setup where, different from the past, on a centralized setup, where with an AM fiber transmission between the CCAP and the node, there was only the possibility to do, say, 8 wavelengths down, 8 wavelengths up maybe, and then with 5-10 gig on a wavelength, this is a disappointing throughput compared to what you can do today on a digital setup. So it's all about, I think, also future-proofing the access infrastructure, because what we see is that it's hard to predict when and how much, and so when everything will happen. But what we all know for sure is that we'll see constant changes in the access technologies that we use. And this goes from DSL for a telco, if we can say so, to fiber for both cable and telco, but comes added, obviously, 4G, 5G, and God knows what next. But it's important that we can also agree and find for ourselves, and that's a big traction in DAA, that we know that going to that migration, to that architecture, is kind of easing the migrations forward. That is also a very important argument when it comes to going there. Now, then also what obviously comes is that when you converge, when you migrate to similar architectures with the benefits that come along, you're going to converge basically traffic on a single fiber, on a few strands of fiber, means that you're going to introduce what is then called a converged interconnect. And that converged interconnect is then basically there to make sure that you have the possibility to aggregate both ways between what is, and I'm going there, what is a lower speed interface on the head-end side, where you see the service cores still most often connect handover at 10 gig. You have a core that runs 100, 200, 400, in some cases can do 800 gig, but you have your DAA nodes, remote PHY, as an example, obviously hand off at 10 gig because that is the standard today. Means that you have an aggregation layer both ends. You have kind of an additional element with 3 layers coming in there. And what is important is that when we compare it with the earlier setup, where you had a traditional node connect to a CCAP platform, the connection was direct, linear. Now it's not longer linear, it's not longer unique. So it is, so they're coming additional complexities, even from the fact that it's not only not longer linear and it's not only longer unique. No, you'll see, because you have introduced a switch infrastructure and because so many of us are engineers, we've immediately realized that this migration brought us enormous benefits when it relates to changing, segmenting basically my network that we all know we need to do, and we'd like to find our best or better ways to go and segment. But then this means that we are kind of evolved in a setup that is not only more complex, not linear, but also becomes a lot more dynamic. You will see frequent changes and impossible to proceed as in the past with offline documentation related to the structure of the network. And this then, I just show it up here as a Rubik's Cube. You've kind of created a cube where I have put my nodes on the bottom layer, and you see one in yellow there, and I have put my service cores on top. And I have, so a time X there on top, and you see that the cores as associated, and I have a color selected for the different, I have a data core, I have a broadcast video core, I have a nowcast video core, there's also out-of-band cores there. But as we evolve, and I think that's also been said already, from appliances to virtual cores, and next to cloud-based cores, then these cores that are associated with my node, they will change over time. Means that I'll have data that is only correct, applicable, and relevant in a very limited time slice, in a very limited time window. And the way they implement it is actually over this aggregation, these 2 aggregation layers and the core that is sitting in between. And then if I have that 3-dimensional framework that I have just introduced, then what we see and what is kind of key for all of us to get the max out of that architectural evolution is to understand the new workflows that will come along with this migration, and to make sure that we've captured them and that we will be able to successfully evolve and execute on these. Means that that is also something that is new. It's added basically change to that migration. So there's obviously a workflow for installation. It's totally different compared to the installation of a traditional node. A traditional node, it was set, you had some EGC amplifiers for sure, but then that programmability was often limited to just the gain and the slope of the element. There wasn't so much to configure, and not so much, I would say, relevance to the firmware and to the feature set as it evolves now in the nodes. So there's equally network rebalancing. You can imagine we are now involved in projects where our customers deploy RPDs that only see 30 customers assigned to these. They combine a full series of these in what is a DOCSIS physical node, and they benefit basically the switch route structure in between the core and the nodes to segment as required and on a click from the console. So very important. Core migration obviously, your appliances will not migrate, but in the context of virtualization, we will today be in charge of spinning up virtual cores, migrating, for example, your cores as associated with an RPD from one data center to another. Is it because of a fire? Is it because you're out of your rent or on that location and will need forward to feed your plant from another data center? All these things weren't totally applicable at all in the past, are completely new. Another one, and also very important, is just firmware upgrades and management. We've had a customer that said, look, for me, I really need that. I've already captured that as something that is extremely important. I want you to take care of the implementation of the workflow around how I'll manage my firmware for my RPD nodes. So, but we've talked about lots of new capabilities. We've talked about new elements. We've talked about added complexity, dynamics in the setup. But what is also important there is that you have, next to all the traditional elements that interfere with your quality of service, you also have, associated with the new SYN components, you have a new series of KPIs, of basically elements that will come and interfere with your quality of service. Hence, more complex, more relevance for the machine basically to come and assist you when it comes to discovering problems that are in the making, or help you with resolving your configuration as quick as possible. So, tunnel and session integrity, we're talking about loads and capacity on interfaces, we're talking about latency, jitter, we're talking about the PTP clock, performance, the architecture, how are we doing, what's the status, the skew that I see on that, and lots of other elements there. Nevertheless, what we see, and I've seen it, and I'm still so stunned by it, is that we've been doing distributed access since 2016. It's 3 years now. But in the beginning, our first implementations, we've seen these, it was really remote PHY. Remote the PHY and put a 10 gig E between the chassis and the node. But it was still static. And that's what also people keep repeating on, and I'll repeat it here again. If you want to maximize at the fullest on virtualization and cloud migration, rethink your setups, rethink your workflows, what you do with it, and try to see what else you can do based on that evolution. And only then we will benefit at the maximum of basically that migration towards distributed access and towards virtual and cloud. And a good example here is that drawing that actually shows where in our initial implementations, the thing we had was a passive splitter. We had a GPON system between what was then the node and the CCAP or the ONT and the CMC. It was as static as ever before. The only difference was we migrated from analog to digital, and we had advantages there. But it could not deliver anything of what we're talking about with our customers today when it comes to supporting convergence, supporting agility, as is definitely also a big element when it comes to maximum or benefits to the architecture. And then you see that your cores, as you find at the bottom, basically, and this is an example with a traditional CCAP appliance, they're basically attached over what is here a core sleeve over a 10 gig aggregation layer to a 100 gig core, and then I'm going back 100 gig, a few times 100 gig, to disaggregation in my node sleeve to basically do a handover to my RPD nodes, again on 10 gig. Because these elements, both sides, they have 10 gig interfaces, but I have my core here that runs multiple 100 gigs. And then our company is all about end-to-end and vendor agnostic, implementation agnostic. If you take everything that you have in scope, for some customers, it only takes 2 vendors' products to break the NMS system. We have, in this example, we go well above 10 vendors from 10 different, product from 10 different vendors, suppliers. Means that is also something that wasn't the case in the past. You were buying your CCAP product from vendor X and your nodes from vendor Z and Y. 3 vendors maybe. You see, I have additional product, I have vendors with a totally different track record, very often immediately different. Go and buy a 10 gig to 100 gig aggregation switch. Buy a 100 gig core, it's not likely gonna come from the same vendor as your RPD node. I'm sure you'll agree with that. So what we see and what is there again the success is you need to have end-to-end reach, an integrated approach. Everything comes with an element management system, for sure it does. But if you were to add the siloed approach that so was talked about earlier already, that is 1 + 1 is 0. Impossible. You cannot work like that. Means that your service platform is not SYN and access aware. Your access platform is not basically, it's often vendor specific, not SYN aware. Your SYN platform is again most often vendor specific and service and access unaware. So no chance for that setup to deliver to your expectations when it comes to supporting the experience and the performance management that you're looking for, to deliver on service restoration within the times as targeted, where you seek to reduce the time to recovery. So then, long story short, and that's also again where the analytics, where the machine that is there, and for us has access to all the data. We don't have an interface to an external data platform that will do the number crunching for us. No, we are the engine. We have the engine embedded into the NMS OSS system, an orchestration platform, and we'll take care of basically integrated management of the workflows that are there, the creation, the maintenance, the execution, the handover. So covering both the operational and the engineering aspects that are basically, that exist around running such a setup. We're basically resource management, end to end, making sure that you are allocating product based on availability, capability, and capacity, that you're not overbooking, that you're getting the maximum out of it. So service management, all the services, it's not only data or not only DOCSIS, no, there's voice, there is, sure, there is broadcast, there is narrowcast video, there is out of band. Network management, reaching from the core all the way up to the CPE, again, end to end, giving you the better results. Inventory information, topology information, status when it comes to elements as well as links. Node association. Remember in the past, the node association was obvious. You had a physical AM fiber link. You pulled the fiber, you knew, look, this is the core that I'm connected to. Now I have 4 links, 5 logical or 5 logical connections that change over time. Customers need to have at all times immediate access. I lost service in this node, in this segment, in this service area. Why did I lose that? What is my cores that support that node? What about the SYN, so core link and aggregation segments that are associated with that node? So service group information, node status, quality of service related data, and also PTP is managed at best into the system. So workflows or jobs, we've talked about it, definitely new, and so something that is very important for many of the customers, taking a very important, relatively very important time to go and define and so have it implemented. And then, so the workflow is for us what we call that a job, and the job will result in a booking. And a booking is a deployment. A booking can be a redeployment. It can be a backup. It can be a rebalancing. We're going to basically convert a request into a booking, basically as an execution against a request. And again, as you see here, can range in its area between operations and engineering, definitely covering both of these. And service and resource management, we have talked about cloud, we've talked about virtualization. I think the show here is an excellent example. It's all about everything as a service. If we want to benefit at the fullest of virtualization, we cannot just virtualize functions, deploy them on a VM, and say, look, I've virtualized my core. Then the benefit for us is, yeah, you can use COTS hardware, yes, but you're never going to get the gain that you can have if you compare it to usage-based billing and for you the chance to switch on the core really when required and terminate it when no longer required. Migrate on the same license from one data center to another, where in the past we see customers today, they have everything twice on 2 sites. They have 400% capacity, so they've invested. What we see is that over the virtualization, definitely these figures will be reduced. So that is something that we need to. But again, what I talked about at the start, migrating from a PON-based DAA application that was there, or maybe an Ethernet-based, but a direct connection between a CCAP node and an RPD, now evolved to a setup that includes an entire SIN. You need to have visibility to the entire network. We're helping our customers today by automatically discovering all the elements, discovering the topology, maintaining the topology as it constantly evolves over time. And you see here, there is just the inventory, there's the view of the element status, there's the view basically of the status of the elements as well as the links. You can see them in tiles as well as in just topology diagrams. And then, as I explained this to change over time, I also need to present my customer at all times with all the associations that are applicable within RPD. At any time when something happens, you have instant access to all the service cores as associated with an RPD, as you should. And so you can use that information to conclude on causes of issues, but also to conclude on necessities to rebalance, for example. And also, as I said, we've earlier seen the entire architecture, but you need to get to your time to recovery targets that you're looking for. You need to have the same or even better speeds of access to the information related to what cores are supporting your node. You see here I show this is an RPD that is connected over a spine leaf architecture, so with a 100 gig core and 10 gig aggregation layers both ways. You see here the CCAP core that is associated with that. Obviously, if you would have a system where your video core is physically separated from your DOCSIS component, then you would just see here 2 different elements. I see here just the virtual components as reside into that CCAP system that holds still the out-of-band, the video, and the DOCSIS all in one. But as we migrate to cloud and to virtual, these things, obviously, we will separate them out. And hence, you'll have here also then the possibility to see, give me the topology for DOCSIS, give me the topology for narrowcast video, give me the association, the topology as is applicable for broadcast video. And that was also something that was, for most of the customers, they kind of shocked. They were they wanted to go there. They wanted to go there, and people say, "We're going to do that. We're going to do that, sure." But then, yeah, we still need that. Yeah, it's not obvious. And we've seen basically vendors that had an open architecture as NMS, and it took only one customer that had routers switches from 2 different vendors for them not to be able to deliver. If I have an open architecture, but you are not willing to support me in an integration, I'll never be able to deliver. We are an independent company. For us, all the vendors are the same. We don't care if you have decided here for the 100 gig core for a different vendor than for your 100 gig to 10 gig aggregation layers. For us, we integrate agnostic from the protocol, from the supplier, we integrate everybody's product. We have integrated product from over 600 different vendors already, and if you have it from a new, basically startup, we'll be glad to integrate that product for you as well. So, another thing, very important, configuration and firmware management. That's also something that wasn't there in the past because your node was often unmanaged. Now it is managed, and again, it has more settings than it had before. Firmware version management is important, configuration management is important, because if you have an orchestrator, you're gonna push a configuration onto an element, but you'd better make sure that before you do that, you have a base configuration that you know and is consistently the same across your network. Then we come to what I think was also core to our message here today, is that we have the need for AI to come and help us. And again, a benefit to our own setup where we have it embedded in the system. Because you can buy analytics platforms. For us, we believe there's obviously truly value in there, but that's just a matter of time before every single platform will have the analytics capability built in. Means that analytics as a standalone, basically, proposition to us, I think, and in this setup, can never deliver to the same levels as we can in an integrated fashion. And so then, we have it basically delivering at best because we do analytics at runtime. Obviously, what my colleague talked about here in the first testing, automated testing, that's a different process. I'm talking about supporting the true operations here. It's a different process. So we've clearly different applications there, but it is a big benefit to have that. It is a big benefit for us that we can relieve our customers from the need to go and set thresholds, to have the possibility to flag problems ahead of them to interrupt, basically disturb the service. It is very, very important. Us to have it all, the data management, the data hygiene, as is often a difficulty when it comes to getting results, the expected return on AI is by us, by default, taken care of because we have it all in one platform. We have the same data base labels, we have the same we manage the structure. We don't need to give it to something else. No, we manage the structure. So we have an optimal data retention setup. We have real-time and continuous learning. We have customers that have analytics in place where they learn tomorrow yesterday's news. If your goal is to reduce your recovery of the service from 5 minutes to a minute, that's not how, you cannot rely on a setup like that. So, and we have all the data. Really all the data. And you can obviously decide what you need, but that is then an excellent position to go and start from. And here, forecasting is an aspect that we're working on. Intelligent fault detection is an aspect that is covered. So incident analysis is something that is covered. And we, for us, what we target, and that's what we also announce to our customers, is to give you augmented operation. Because all of us are dealing today with the need to do more with the same staffing at best. Means we need to become more efficient. We need to support you in delivering a platform that allows you to do more with the teams that are there and that are not obvious to go and grow. Trend forecasting, behavior anomaly detection, configuration anomaly detection, incident recognition, so root cause analysis, and advanced, so cap detection is an example that I have here with me. Means that our engine learns basically about the behavior, and our engine is capable to predict where we're going. And you can say that's nice that you know where we're going. But what is even more important is that based on that visibility that the platform has, where you're going, it can flag you problems before they will impact you. means that I can now, this afternoon, get a note from my platform. Please look that, because this will kill you tomorrow at 6 o'clock. And then you have, as an operator, the chance to proactively address a problem without the reality that your customers are screaming and droning your customer service center already. And this is what we are looking for as a solution provider for you, and also as a customer yourself. And that is just the same thing. This is yeah. Okay, I'm done. So this was another example, and here I'm done. Means that, long story short, and this was just, it is a very, very, I would say, promising architecture. I think it's not only promising, I think all of us, they're going there. And I just wanted to highlight here today is that as it is a promising architecture, we just need to make sure that we correctly understand all the consequences that come along, and so that we also think about the workflows as associated and the choices we need to make, the aspects we need to cover to benefit at max from this new architecture. And advanced analytics is an integral part of us successfully migrating to that architecture. And that is what I had here for today. And I thank you very much for your time here.
Thank you, Dominique. I see no questions from the audience. To be honest, Dominique, I was a bit overwhelmed. I'm an old student. I studied electrotechnics 30 years ago, and we're just connecting wires to each other, but I understand from your presentation that's not needed anymore. It's all done dynamically in the CIN. On stage, I have two real experts. You probably understand what you talk about.
Yes, I got two questions. The one that was going around until about the last minute that you were talking was quantizable data. Of course, this is DAA, and that's relatively new. But is there any way of gathering, well, you're using a system without AI, and you're using a system with AI, and if you're using it with AI, it's like X% more efficient. It's probably hard to do, but is there anything like that? That's my first question. And second is, you're talking about, last sentence was proactive network management. Does that tie into proactive network maintenance, analyzing pre-equalization coefficients in any way behind the node?
It didn't. I know the concept, but so proactive network maintenance is a subject that we cover as well. Mm-hmm. But that is then based on basically the analysis of MER data and reflection, group delay. So and we're working with that as well. But the focus for today was how we will now let you know upfront, but based on other KPIs, that you have a problem in the making, and giving you the possibility to proactively correct and avoid an outage. It is a different context. It's also proactive. The aspect that you're talking about, we've equally covered, but I didn't touch on that today.
And the first question?
The first question is, it's difficult. But what I wanted to bring here today, and that's, I think, what is important for everybody to realize, is that we should not only look at root cause analysis and proactive incident basically discovery and the possibility to act quicker as the sole benefits to machine learning. For us operators, what is also very, very much very important to realize is that you will not be able to set thresholds. You don't need to set thresholds anymore forward. And that is also a big thing. And also, there is lots of basically scenarios, and I can show them at the booth, where basically a problem, it's a problem that it is not there. It means that you should have a pulse, and if the pulse isn't there, then you have a problem. But with a threshold, you can never be triggered on these things. So there is benefits also upfront in the configuration cycle, not only in the service recovery or assurance cycles. And that's what I think is also an important thing that I wanted to bring. But it's difficult.
So the question from Alexander is, what is the benefit from having AI or have not? Yeah. It's difficult to answer.
No, I think the benefits are clear, but he was asking me to quantify it, and that is very, very
difficult. So you are satisfied with the question?
Absolutely, okay. Because it's relatively clearly to say it's always and good engineering answer is always, it depends on the boundary conditions,
So
right?
that was okay. Okay, Dominique.
I would agree to that.
Thank you for your time and thank you for
My
your
pleasure.
presentation.